All right, so missed number 2, but there it is. If you're watching this video, there's number 2. Down to number 3. This one's not too bad to count. I'll count this one myself. Looks like we're going over 1, 2, 3, 4, 5, 6. And we're going down 1, 2, 3, 4, 5, 6, 7, 8. 6 and 8. 6 squared and 8 squared gives us 36 and 64. Add those up and get 100. Take the square root and we get 10 units. Nice and even, right? Everyone all good so far with those first 2? Okay. Number 4. Anyone got, what are the 2 numbers here for number 4? Is it 15 and it looks like 8? Yeah, there we go. 15 and 8. Square both of them, we get 225 and 64. Add those together and get 289. And this number had a couple people stumped, but if we refer back to our perfect square chart on note sheet number 2, we see that the square root of 289 is what? 17. That's right. It's a nice perfect square. It's just not one that we typically see very often, right? So still be aware of that number. Questions on the front before we move to the back? Beautiful. Now, number 5 is a little bit of a trick question here, right? Because if we're counting our spaces from point to point, it looks like 1, 2, 3, 4, 5, 6, 7. Now, how many spaces do we have to move left or right? None, right? So, 7 squared and 0 squared. Those are going to be our 2 numbers. Now, we don't technically have to do this process because we can see that these 2 points are only 7 units apart. That's going to be our answer. But let me show you, if we followed our method, what would we get? Well, we'd get 49. 0 squared is just 0. After we square them, we have to add them to get 49. And when we take the square root, we're right back at 7. So if we have 2 points that are directly in line with each other, either vertically or horizontally, all we have to do is count. It's only when the points are diagonal from each other, like here, that we have to do this kind of broken down distance formula. You see what I mean? That was a pretty straight line without a ruler. Thank you. All right. Anyway, number 8. What are our 2 numbers here for number 8 that we're using? 12 and what? 15. Perfect. Square them. 144, 225. Add them. What's that going to be? 369. Now, is 369 a perfect square? No. No, it's not. But we see that all 3 of our numbers here, 3, 6, and 9, those are all divisible by 3. So we can factor tree this into 3 times 123. Oh, let's go. Okay, sorry. And then we can split 123 into 3 times what? 41? Yeah, 41. 41's a prime number, so our factors are 3, 3, and 41. If we put those inside our square root, we can see that the identical pair we're taking out is a pair of 3's, and the 41 stays behind. 3 root 41 units. Right? I saw a couple people write 3 root 43 units. Super close. I probably honestly wouldn't even take a point off because that's really close, but make sure we're getting our division right, okay? It's one of the other ways that we can mess this up. But onward to number 6. I realize I messed up the order of these numbers. That's my bad, but still 10 problems is 10 problems. So over here we're at -5, over here we're at 1, so that number is 6. And then we go from 1 to 7, that's 6 again, right? 6 squared and 6 squared gives us 36 plus 36, which is 72. Now when we break up 72, we can break it up into 8 and 9. Right? 8 breaks up into 4 times 2, 9 breaks up into 3 times 3, and 4 breaks up into 2 times 2 again. I've seen quite a bit of instances where people forget to break up the 4 when they're doing their factor trees. We have to remember to break it up as much as we possibly can. We got a pair of 2s and we got a pair of 3s with a single 2 left behind. That 2 and that 3 that we bring out of the square root are going to multiply in front, giving us 6 root 2 units. Right? 6 root 2 units. Bless you.
Thank you.
Moving across to number 9. This one's not too bad. It looks like we're going over 7 and 6. 49 plus 36 gives us, what is that, 85? And some of us, we saw when we broke up 85, we got 5 times, what, 17, I think? Yeah, 5 times 17. Now those are both prime numbers. We can't split those up any further. So our answer will remain root 85 units. Not 85 units, right? Not 85 units, the square root of 85 units. Remember, if we estimate our square root, we could say that the actual distance between these 2 points is in between 9 and 10 units. Victor?
But did you break down 85?
So 85, if we break it down, all we can do is 5 times 17. We can't split the 5 up, and we can't split the 17 up. And there's between these two factors, there's no identical pairs to pull out, right? If we wanted to continue this, it would be 5 times 17. There's no pairs here that we can bring out, so we just have to leave them behind. Does that make a little sense?
Yeah.
Perfect. Great question. Welcome, sir. Down to number 7. Thank you. Down to number 7. Looks like we're going over 5 and we're going up 6. Squared, squared. 25 plus 36 gives us, what is that, 61? Right? Is that right? That's right, right? Yeah.
Yeah.
And when we take the square root of 61, again, that's a prime number. Can't do anything. But we have to make sure our answer is the square root of 61 units, not 61 units. Very, very different things there. And then for number 10, we've got 5 and 5. Square them up. 25 plus 25 gives us 50. 50 is 5 times 10. 10 is 5 times 2. So we get 5 root 2 units. Here's something interesting I want to point out real quick. If we take a look at number 6 and number 10, right? Number 6, we had 36 and 36 as our 2 numbers, right? And that gave us an answer of 6 root 2. So that root of our perfect square on the outside with a 2 left over on the inside. Down here on number 10, we had a similar situation. We had 25 and 25, right? And that gave us 5 root 2 units. So that 2 is still staying back in the square root, but the perfect square roots of 36 and 25 came out in front. Anyone notice that? It's okay if you didn't. It's kind of not important, but just something interesting to point out if you caught that pattern. All right. Any questions on the front or back of worksheet 57 before we get moving here? Perfect.